This is higher computing, the computer systems unit, and within that the computer structure topic. This is lesson 2 on memory types. And in the last lesson we looked at the von Neumann computer model, which you can see here, and within it we looked at the 3 parts of the processor and how it uses buses and control lines to send data to and from main memory. In this lesson what we're looking at is the different types of memory, so you can distinguish between them, and also you know a bit more about the sort of speed of access and maybe the cost implications of this different types of memory. And you should also know a little bit about it as well. So what we're going to do is start off with the idea of main memory, and typically when you think of main memory you think of RAM and ROM, but there's actually a lot more to it than that. There's different types of RAM which can be changed, can sort of temporarily hold values, and there's also different types of ROM. So at a higher level you have to be able to explain a little bit more about it. The memory you see here in sort of the red boxes, you can see that they start at the bottom of the page with the registers which are actually on the processor, and the level 1 cache which is usually on the processor or very close to it. So I'll just zoom in a little bit. Now you should know the registers are very short-term, very small short-term storage locations, and holds things like data to be processed, addresses to be accessed, instructions to be executed. And because they're on the processor, they're very fast to access. So as you can see, a nanosecond to access the data that's held within registers. But the trade-off for that is that there's not actually very much data that can be stored within each register. So you have to do quite a lot more calls or accesses to that register. Basically, it's not something you want to be storing, or you could possibly store a large program in. It's got to be just small parts, maybe like a web address or a memory location or something like that. Now moving away a little bit from the processor, you've got level 1 cache. This is an access time of 5 nanoseconds on average, and basically cache memory saves a copy of the most frequently used data. So this might be an image that is repeatedly loaded from a website, or it might be the address of an MP3 file that you enjoy playing, and it's quite high up the playlist, something like that. Okay, still fairly small, but slightly larger in size than the registers. And again, fast access. Moving up a little bit, we've got level 2 cache, which is just outside the processor and moving away from the processor physically on the motherboard, and it's 15 nanoseconds average access time. There is a level 3 cache as well, but we're probably not going to go. It's not worth going into for this topic. However, it usually consists of these two types of memory. You've got static RAM or SRAM and dynamic RAM or DRAM. And as you can see, the static RAM is much faster to access. It's between 10 to 20 nanoseconds to access, compared to the dynamic RAM, which takes 50 nanoseconds to access. The static RAM is usually found just outside the main memory location on your motherboard, where the dynamic RAM is actually on or within the main memory section. So it's the RAM chips basically that you install into standard computers. Static RAM, although it is much faster, it is far more expensive, and that's denoted with the gold bar there. So if you want to have much faster access speed or access times to your data that's been held in main memory, then go for static RAM, but it's going to cost you a premium. The cheapest and more efficient, most efficient use of your money is to go for dynamic RAM, and lots of it, so that you can store a larger amount of data that's going to be accessed much more quickly. And you'll see in a second why dynamic RAM is so popular. Next to dynamic RAM, within the area of main memory, you also have ROM. Now you'll remember ROM from standard grade, or maybe even from S1. ROM stands for read-only memory, so this usually cannot be changed. However, at a higher level, you realise that there is actually some parts of ROM that can be changed, things like flash ROM. So flash ROM has a tiny or a very limited area of storage which can be altered through an electrical charge that's passed through it. And this holds things like your BIOS or bootstrap loaders, which is the sort of header up here. Bootstrap loader, just to let you know, is a part of the operating system which runs to tell the computer where the rest of the operating system actually resides on the hard disk drive. So it's a very small program that basically just tells it what to load next. Other types of ROM which you can change are PROM, which is programmable ROM, and EPROM, which is erasable programmable ROM. And these two types of ROM can be changed. The PROM can only be changed once, and then it's fixed forever. So that's sometimes used for mobile phones. EPROM is erasable programmable ROM, and that can be reused. So that's in things like sort of programmable robots. You've got an element of PROM inside, or flash ROM, I suppose, similar inside things like wireless games controllers and things where they can register with devices. Same kind of access speeds, 50 nanoseconds, because of the location on the motherboard. It's exactly the same as your DRAM, so it makes sense it's the same speed. Now this is not the slowest type of RAM or ROM. Comparatively, all those types of memory that we've just talked about are fairly fast access. You can actually use your backend storage as slow access memory, and this happens quite a lot with Windows machines, for example, when you run out of physical RAM, and so it starts to create virtual RAM. Okay, so it basically just uses your hard drive as or a section of your hard drive as an area of memory which you can sort of read temporary data to and write temporary data to, and that is why you sometimes hear your hard drives churning when you're running a particularly large application. So virtual RAM, access speed of that is 1,000,000 nanoseconds, which is an awful lot more than 50. So virtual RAM is by far the slowest type of memory that you can access, but because it uses a hard drive, it's probably the cheapest on balance. So you have to sort of decide whether you want to, if you want something to run super fast, then you have to have lots of either static RAM or dynamic RAM chips to reduce or remove the need for your operating system to create extra virtual RAM from the hard disk drive. It's a difficult decision. It always comes down to cost.